the next question comes that what programming language we can use for this. So I would say that most of the major programming languages we can use for the OpenStat. Some of them are listed here, like Excel, VBA, Python, C#, C, C++, VB.NET. We can use all this programming language to work with OpenStat. Okay, now let us check that what are the operations that we can done using OpenStat. So basically the operations we do in StatPro in our daily job, we can do most of the operations using OpenStat. So like creating any complex geometry or assigning any material, section, property, loading, or assigning any design parameter or analysis parameter. So we can do that using function. And also after analysis is completed, we can extract the result like plate stress or displacement or summary or member force. So we can do most of the task using OpenStat function. Now let me give you a demo that how we can achieve the process explained by Sanjeev in our earlier session using programming language. So the process explained by Sanjeev requires actually some manual effort, that we need to figure out that which bracing members are in compression and which bracing members are in tension from the static seismic loading. And then we need to assign the member inactive and then member truss specification to the response spectrum loading. So you can see a lot of manual work is required in this process. And there will also be a chance of error. So to minimize the manual work and also to minimize the chance of error, I am using here one macro. So let me show you the stat model. First, what we have to do, we have to create 3 stat model. So first stat model will be with the static seismic loading. So here you can see only I have applied the static seismic loading in X direction and then in Z direction. And the next model will be the response spectrum loading. Here I only have applied the response spectrum loading in X direction, and I have not specified any inactive or truss specification in this model right now. And the third model will be response spectrum loading in Z direction. So I have applied this response spectrum loading in Z direction in this model, and also in this model I have not assigned any specification yet. Now I will do all those things using a programming language. So let me show you the macro I have created. So to use the macro, first you need to open all these 3 stat model in the background. Then I will open the macro. This macro and this model will be shared with you later on this session. So I will explain you how you can use this macro. So first, let me choose the location where my static seismic stat file is there. So for that, I need to click on this 3 dot. And here is my static seismic model. So I am choosing the model. So in this location B1, you can see the path of the static seismic model is provided. Then I will click on this Get Data tab. Now a window will open. Here I need to provide some of the inputs. So the first input will be the group name. So let me show you the groups I have created earlier. So I have created 3 groups. The first one is the bracing group. That is basically I have created this group using all my bracing member. So I need to choose the bracing as my group here. This is my first input. And second input is basically the load case number. So for me, the load case number 1 is for the static seismic loading in X direction, and load case number 2 is for the static seismic loading in Z direction. So I will provide here the load case number. And if I just click on the get data from model 1, so what happens here that the number of the bracing member and start and end node of the member are extracted. But as my model is not analyzed, so it is asking me to analyze the model first. So let me do that. It's done. Then if I again click on this get data, you can see all the informations are basically extracted. So what informations I have extracted here? these are basically first the base unit, that in which unit the forces are extracted, that is my kilonewton meter, and then the member number. This is actually the bracing member, the group bracing member group, and then the start node and end node of the bracing members. Then I have extracted the Fx, that is the actual force of each of the member. Then I have figured it out that which member are in tension and which member are in compression. So how I can figure it out? That in this slide, you can see that if the Fx has the positive sign at the start node and Fx has the negative sign in the end node, then the member will be in compression. And if the Fx has the negative sign in the first start node and Fx has the positive sign in the end node, then the member will be in tension. So to figure out which one is the start and end node, we can press Shift E in the keyboard, and we can also figure it out with the local axis of the member, and by pressing Shift O, we can find out that which the member local axis orientation. So with this process, I have figured it out that these bracing members are actually which members are in compression. So let me just highlight again the group, that in this bracing member group, that which members are in tension and which members are in compression individually for both the load cases. That first is the static seismic X load case, and then another is the static seismic Z load case. And in the sheet 2, that is the summary sheet, I have just concised the data, that how many members are in compression and tension and what are the member number. So this is the concise data. Now what we have to do, we have to just assign the bracing member with compressive force as the member inactive in our response spectrum model, and the bracing member with tensile force as the member truss in our response spectrum load. So visually it can be seen like that, that this is the loading in X direction, and the red color members are in basically compression. So we are assigning the member inactive for this compressive member, and the blue color members are in tension. So we are assigning member truss for the tensile force. Same thing is done for the Z direction. This is my loading in Z direction, and same methodology is applied for the Z direction also. Now, how we can do that? If you want to manually assign all those inactive and truss specification for both the model, it will take a lot of time, and there is a slight possibility of error, that we may miss some of the beam. So it is better to use the programming language. So how can I do that? So again, I will choose this get data option, and here I have to provide the location of my these two STAD model. The first STAD model is basically the response spectrum load in X directional STAD model. Then the second model will be the Z. So in this field, I have provided the location. Now, if I just click on the next tab, that is assign specification and analyze the model, let us see what happened. So what I am doing basically, I am assigning the inactive and truss specification to the members, and in the background also the analysis process is going on. So all those things I am just doing it with the help of programming language and OpenStat function. I am not doing any of this manually. Once it's complete, I will show you the STAD model. So this is the STAD model with response spectrum S. So you can see the member inactive is applied as per my methodology, and member truss is also applied. And here the response spectrum Z and truss is applied for the Z model. We can see that in the input, that this is the inactive command and this is the truss command, and also the model is completely analyzed. Now all these processes are done. Then what we have to do, we have to just extract the utilization ratio for this two model. So the requirement is actually these two fields cannot be blank, because we are extracting the information from these two STAD models. So if these two fields are blank, it will not work. We have to choose the location here. Then we have to provide the ratio parameter. What is ratio parameter? This is the permissible limit to the actual load to the allowable strain. So by default, the value is 1. I am not changing the value. What I will do that I will quickly click on get utilization ratio tab. So what I am doing that in the third sheet, what I have done is I have extracted the still design result. What I have extracted, that first the member number, all the member number, then design section, then the utilization ratio of those all those member, then the critical load case number, then the corresponding load case title, then the critical clause and design status. So I have done all this process for the two model, that is with the response spectrum X and response spectrum Z. I have again done another thing, that I figured it out that which utilization ratio is maximum, and that is for the which model. So if I check, this is for the column M, if I check the first utilization ratio, it is 0.11, that is the maximum one. And for response spectrum Z model, it is the maximum. So I have highlighted those cell in yellow color, and I have also reported the file name, that for which file that is maximum, I have reported this information also. So you can see all those things just required like 5 to 7 minutes to complete the whole process. So that is the advantage and power of using programming language with StatPro. You can just do all those tasks very easily and very quick. And the biggest advantage is basically that you can use this macro multiple times for any kind of model. So I am reducing my manual effort, and I am also reducing the chance of error. So I am just doing all those things by automation. Okay, now let me show you that what are the functions I have used in my in this macro, in this Excel file. So for the sheet 1, that is where I have extracted the forces, I have only used this function. So these functions are basically to extract the member group, and then how many members are present in that particular group, and also I am extracting the member number of the particular group. Second thing what I have done is I have extracted the start and end node of the member. Then according to the start and end node of the member, I have extracted the axial force using function this get member end forces. And in the second sheet, where I have just reported the concise data, I have assigned the inactive and trust specification from this data. So I have used this first two functions to create the specification. Then the third function is used to assign those specification to my bracing member. Then automatically I have analyzed the model using this particular function. And in the third sheet, where I have extracted the utilization ratio, I have used these 4 functions only. The first function is to retrieve the stat model, and here it is reported. You can see the stat model name, and here also. And I have find out how many members are there in my model, what are the member number of my model. And with this particular function, still design result function, I have extracted all the still design result, that is the critical load case number or critical clause, design status, utilization ratio. I have extracted all this information using this particular function. Now you can just you can extract other information also, like critical section forces or maybe the critical section location. So as per your requirement, you can customize it as per your choice. So these are the function I have used to create the whole macro. Okay, now let me show you some location where you can find some ready-made macro that are available. So first is the location in the C drive. If your stat is installed properly and with the default directory, so in this particular location, you will see some of the macro files are provided. So you can check it out. And also in the Bentley community side, some macro files are also provided. So you can check this particular link and Stat API solution. There are some ready-made tools are available. You can download it and you can use it in your daily job. Okay, now if you want to create your own macro, so you might have like wondered that where are the functions, how can I check the functions? So for that, if you go to help, StatPro help, and if you just go to OpenStat help, all the functions are documented in our OpenStat documentation. And it is a very organized way it is documented. So all the modules are there, and all the functions related, each of the module is documented like the use of the function, then the input and output parameter of the function, then a sample small syntax is also provided that how we can use that particular function. And if you want to use any other programming language other than VBA, then you can check out this link. This is part of our StatPro help manual. So if you go to the OpenStat section, you will get to see some of the links, and you can check this link also to use programming language, other programming language. Okay, these are the help. And now if you want to learn that how we can create our tool, how we can customize our work, how the OpenStat function works, so you can check out these 4 videos. These are like a tutorial video for the OpenStat. So step-by-step process is provided that how we can use OpenStat function and how we can link StatPro with the third-party software. So please check out this link. Please try to explore that and use it in your daily job. And the next thing is, if you require any help from our side, or if you have any query or any doubt or require any advice, please you can post your query to our Bentley community site. And also you can call in our toll-free number that is provided in the slide. And also you can just post your query in the service case. So if you just log in into connect.bentley.com and you can create a new case, and please let us know your query, your doubt. We'll be happy to help you out. Thank you, everyone. Hope this session is helpful to you, and hope you will continue using OpenStat. Thank you, everyone. I just hand it over to Sanjibda to continue further. Thank you.
Okay. Am I audible, Shriyanka?
Yes, you are.
Okay, perfect. So we have seen, a lot of stuff we have done, and, here we have understood small problems that, in a single file, we cannot actually cater the requirement of tension compressions, right? So we will be supplying in the very next slide a particular link where you can download the macros and with this particular file. So one of the most important stuff is that whenever you just copy this macro to a particular folder, you need to right click on that one and make sure that you check on unblock and click on OK. Otherwise, that particular macro will not work for you. So this is the link. You can just click on that particular link to download the macros and instruction to use it. And we have got the clear guideline how to do that one. And we have just provided this particular informations or that particular models which we have used for today's session. So I'm giving you some time so that you can download it. And you can use it. So please click on that particular word. Please download macro and instruction to use. This will download that particular macro for you. Okay. So I believe all of you have got the sufficient time to do this. Let's move on to the last portion. So what is the conclusion we can make out of this? The software cannot solve nonlinear cases in response spectrum analysis. This is by the, this was the RSA, response spectrum analysis was not, developed to handle this kind of situation. So we need to use an alternate process, and we should have created 2 files with the active bracings, meanings those bracings which are in tension specified as member truss in X and Z direction in 2 different files. And we have to be very, very proper active bracings, meanings the bracings which are been assigned as member truss should be proper to be used as for the analysis that has been performed in X and Z directions. And we have provided you with a macro and the sample file that will be helpful for you. If you are thinking for the -X and -Z direction, you have to create 2 other files. and considering this. We haven't considered this because it may create some confusions because the data will be lost, but you need to create two other cases for that one with the loading in -x and -z in the static cases, and then you can find out this analysis and design results are to be checked properly. So in this purpose, we have supplied with you a macro. So with this, we would like to conclude today's sessions, and we will definitely take a few questions from you. And before that, we would like to know what type of dynamic analysis you are using. This is for the fact that the next topic will be with your response. So please choose one of this particular category in order to just let us know what should be our next topic discussions, with some help, with some macros which you can use in your daily life. Okay, thanks. Next, go to the next sessions. Which seismic design code you are using? IS 1893 Part 1, Part 2, Part 4. Part 4 is not been implemented. Part 2 is not been implemented instead. So just your vote will help us even to implement that one in the software. So we require your stuff. We have AC07 or IBC, and EC8 code is already been implemented. So depending on your choice, on your requirement, we will be coming up with our next sessions, and even we will try to implement those codes which are not been implemented in StatPro. Go to the next one. Which Bentley software you are using? Please take your time and vote it. And that is also that will also help us to come up with our next topic. Okay, thank you. So this is another important thing. Which topic you want us to cover the upcoming sessions? Whether it's an OpenStat macros, dynamic analysis, normal seismic analysis, steel design, or concrete design. So please vote. Okay, so thank you. And Sriyanka, if you can read out one or two questions, we will be just discussing that one. So do you have sufficient questions over here?
Yes. So I just want to say this thing to all of you that the macro is not actually, the link is not working for many of our users. So what we'll do, we will share the macro and the stat file separately so that you can download it. So no worries. The recorded link will also be shared with you. So no worries for that. Okay. Now let we check some questions. Okay, the first question is, when we are combining different modes, are we combining force or displacement or something else?
So actually, all the responses, I mean, if you just look into, after doing a response spectrum analysis, if you are finding out the final member forces, say axial force, bending moment. So these things are being computed in each and every mode that you are using. And I have seen one question that by default STAD, analyzes for 6 numbers of mode. So you can, if you are not achieving 90% mass participations, you need to use cutoff mode shape to a number by which you can increase that to 90%. So that much of mode will be in each of these particular numbers of modes. All the responses, responses means support reactions, member forces, nodal displacements, that will be computed each and every mode, and final result that you will be getting will have the effect of each and every mode, and the final result will be unsigned, and it will be coming from the modal combination method that you are using. Okay, go to the next question.
See one